Okay, let's give you guys some practice. So find the volume underneath this surface, in this specified region. So press pause and have a go. Okay, so to do this, let's sketch out this region. So looking at the region, y equals 10 minus x would look like this. It's a straight line, intercept of 10, gradient of -1. So it looks like this, 10 and 10. And if you look at the x must be in between 0 and 3. Well, 0 is here, 3 is here, and remember y has to be bigger or equal to 0. So we are talking about this region here. So the region we're interested in is this region here. And when you're looking at dA, you have the option of using dx by dy or dy by dx. So let's look at this scenario here, dx by dy. Well, dx by dy, because this is if you look at the inner integral, it has to move parallel to the x-axis. So you've got to move like this, parallel to the x-axis. So you're moving along like this. So that would mean x equals something. But then if you move in the x direction, you would have to do this. You start here, you stop here. You start here, you stop here. You start here, you stop here. So you're moving along like this, and you always stop at x equals 3. But then by the time you get to this point here, then now you're moving along the line. You see, here you're moving along, you stop at x equals 3, so you're stopping along this line here. You're stopping along this line. But then as you progress, by the time you get to this stage here, you're stopping at the diagonal line. So here, if you use this one, it would be a lot harder than you using dy by dx, because if you look at dy by dx, well, you've got to move parallel to the y-axis. So dy by dx is much easier. So you're just using one integral here. For up here, you have to set up two integrals. So you're moving along like this. So that would be one integral. And then the next one, you're going to have to set up another integral for the diagonal line. For this one here, you stop at the horizontal line. Well, it's easier to use dy by dx. So let's use this one here. So dy by dx would be like this. Well, looking at the inner integral, you're moving parallel to the y-axis. So this is the y-axis here. So you're moving along like this. You're moving along like this. You're moving along like this. Well, that would mean, because you're moving in the y direction, that would mean y equals something and y equals something. So you start here, you stop here. You start here, you stop here. Well, where do you start? You start at y equals 0. You start at y equals 0. And where do you stop? Well, you move along here and then you stop at that diagonal line. Well, this diagonal line is y equals 10 minus x. So that would mean you stop at 10 minus x. And so that's your inner integral done. Now looking at the outer integral, the outer integral will have to be bounded by a constant. So you're moving along like this. You're moving along like this. You're moving along like this. So you're scanning all the way from 0 to 3. You're scanning all the way from 0 to 3. So that would mean, this is x here, so that would mean x equals something. X equals something. Well, you start at 0, and then you're scanning all the way to 3. So this is how you set up the volume here. So really it boils down to you integrating this. So setting up the volume correctly would give you this. So now it's just a matter of integrating this. So we've got to integrate the inner integral with respect to y. So that means that this will be a constant, and then when you integrate this, the power gets increased by 1. So it would be y squared and then divided by 2. So that would, well, integrate this thing with respect to y would then give you this. So now it's just a matter of you putting this into the y, and then take away, put 0 into the y. So that would then give you this thing here. And then it's just now you've got to integrate it with respect to x. So let's multiply this out. That will then give us this thing here, and then multiply this. That will then give you this thing here. That will then give you this thing here, and then now you can just integrate it with respect to x. So integrate this with respect to x, and then integrate this, integrate this. Remember, it's from 0 to 3. It's from 0 to 3. So now you can put 3 into here, 3 into here, 3 into here. That will then give you this, and then take away, put 0 into here, put 0 into here, put 0 into here. It will be take away 0, take away 0, take away 0. So the volume is given by this. Okay.